Hi, I'm Ms. Wong. Today we're going to look at horizontal translations with sine and cos graphs. Horizontal translations. Remember when we did quadratics in the turning point form? For example, if we had x minus 3 all squared, what did that do to the graph? The minus 3, so x minus 3, shifted our parabola to the right by 3. If we had x plus 3 all squared, it would shift our parabola to the left by 3. Similarly, we can do the same thing with sine and cos. We can add a value inside the bracket to shift it left and right. And we call this shift a phase shift. And the epsilon, that little e there, we describe it as a translation of minus plus epsilon in the x-axis, because if we had plus in the bracket, we're moving to the negative direction of the x-axis. If we had minus epsilon, we would be moving in the positive direction of the x-axis. That's why it's minus plus in this description. So let's have a look at some graphs. Let's say we had sine x minus pi on 2. So this time we're shifting to the right by pi on 2. So first let's sketch the original graph of sine x, which means we start at 0 and it's 2 pi a period. So we start here and up there, halfway we go through the intercept, we go up to the maximum halfway of this, so that's 1, and we go down to the lowest point between pi and 2 pi, so at 3 pi and 2, and we sketch the graph. So that's sine x. So shifting it by pi on 2 to the right means all these dots will be moved to the right by pi on 2, just like so. And then we finish off the graph by sketching any missing sections. Let's do another one. Let's observe what happens with cos. If we had cos, for example, plus pi on 4, this time we're going to the left by pi on 4. So let's sketch the original graph of cos x that starts at 1, and then after the period of 2 pi it ends up in the same spot. Halfway it hits the lowest point, and halfway of these two hits the x-intercept, and halfway that and that at 3 pi and 2 it hits the x-intercept. So that's our original graph. Oops. And if we want to shift it a quarter to the left, means that's a half, so a quarter to the left would mean that amount to the left. It will look something like that. So how do we sketch this? Let's do some examples. Example 1, sketch 3 sine 2 x minus pi on 4 between pi on 4 and 5 pi on 4. So for the 3, we know that's the amplitude. That means from the middle it goes up to 3, and from the middle it goes down to negative 3. So the range is negative 3 to 3. What does the 2 tell us? It tells us the period is 2 pi on 2, which is pi. And now we have a new value. It has been translated by pi on 4 to the right. So how do we sketch this? Well, let's start with the axis, and we know it goes from negative 3 to 3. And we know the period is pi, and we need to go all the way to 5 pi on 4. So let's put pi there and split it up in half, and then in half again. And then we go by pi on 4. So pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4. So now we have covered our domain. Now that we have the axis, we know where to start and where to end. But let's sketch the original graph first. If the original graph without the translation, it would look like this. It's a sine graph, so it starts at 0, and then it goes up to 3 and ends up at the end of the period. The end of the period is pi, so we have to end there. So I'm doing the graph with everything except for the translation. So it starts at 0, ends or repeats at pi, halfway there, halfway pi is 2 pi on 2. It goes through the x-axis again. The highest point between these two would be at 3 when its x is pi on 4, and the lowest point will be between these two dots, which is at 3 pi on 4, and it will be at minus 3. So the original graph will look like this. What about the translated graph? So we take each of these points we have, and now we move it to the right by pi on 4. So this point here is going to be now here. This point here is going to be at pi on 2 and 3. This point here is going to move by pi on 4 as well. This one here is going to go to pi. This point here is going to be at 5 pi and 4. You can see that we take the special points and we move it by the translation, and it's good to have your scaling the same as or a multiple of the denominator of the translation. So now we have these dots, we can join them up, and we checked our domain. It's between pi and 4 and 5 pi and 4. So pi and 4, we start here, that's perfect, but we have to stop there. So let's get rid of that bit. So you're always welcome to sketch roughly what you want it to look like, and always get rid of things after. Example 2, sketch y equals 2 cos 6 x plus pi and 6 between minus pi and 3 and pi and 3. So the 2 tells us the amplitude, which means our highest value is 2 and our lowest value is negative 2. The 6 gives us the period, 2 pi on 6, 2 pi on 6, 2 over 6 is the same as a third. So the period is pi on 3. The plus pi on 6 is the translation to the left by pi on 6. We'll worry about that bit later. Now the amplitude minus 2 and 2 and the domain of minus pi over 3 and pi on 3 means we're going to sketch our axis like so, put in the 2 and the negative 2, then we're going to put in the domain of pi on 3 and negative pi on 3. Now the period is pi on 3, so our graph is going to go up and down by the time it gets to pi on 3. So let's put the values or scales in between there. So between 0 and pi on 3, halfway is pi on 6. Let's do that on the other side too. Let's sketch our graph. So it starts at 2 and then it ends up at 2 again after a period, which is pi on 3. Halfway of that it's negative 2 at pi on 6. Halfway of these 2 it's going to go through the x-axis, and halfway of the other 2 points it's going to do the same thing. Let's sketch that, and we continue the graph on the other side. Now that we have that, we can move the points and complete the actual graph by sketching it translated pi on 6 to the left. So the first point gets moved pi on 6 to the left, the next point moves pi on 6 to the left, and notice that I'm using a different color pen this time so I don't get confused. So now I'm going like that. So let's sketch that, and then we're also going to sketch the other side and get rid of things that are outside our domain. This one was quite tricky. You can see that it's almost like, how else could you describe this? A reflection on the x-axis, but it's translated half a period, and that's what happens when you translate half a period. It looks like a reflection. Okay, thank you for watching. Practice again. So the steps were, have a look at the values and then sketch without the translation and then translate after. Okay, thank you for watching. I'll see you next time. Bye.